Services in ASP.NET Core Dependency Injection have three kinds of lifetime. Service lifetime decides when a service is constructed and when is it disposed. Hi there, how are you doing today? This is the third episode we talk about dependency injection. And today's topic is about the lifetime of the services. If you don't know what a dependency injection is or what's the benefit, check out part 1. And you're wondering about the basics to use dependency injection in ASP.NET Core, check out part 2. Now, let's talk about the lifetime. According to the official documentation, there are three types of service lifetime. They are singleton, scoped, and transient. Let's put on a lifetime of an application on the paper. Let's mark here at the start of an application, and then here at the end of the application. A singleton service starts when it is initially injected and ends when the application ends. During the lifecycle of the application, there are multiple requests. A scoped service starts with the injection of the service and ends when the request finished. During one request, if the same service got injected several times, all scoped service will share the same one. But if a service is registered as a transient service, each injection will lead to a new instance of the service. Don't worry if you feel, huh? At this moment, I'll explain it with code. Let's start by creating a web API. I'm going to create a class called Lifetime Inspector, and I'll use that to reveal the lifecycle of the service itself. On the constructor, I'm going to inject an iLogger instance of this class. The idea is during the different phases of the class, I'm going to output the messages through iLogger so that we can see when those phases happen. At this stage, you should be very familiar with how this iLogger gets created and injected into this class, and what I'm doing here is to save it to a field so that it can be used in different places. While I am here in the constructor, I'm going to output a message so that we will know when an instance is created of this class. And to identify the specific instance, I'm going to give it a GUID as ID. Let's output the value in the message. Now, to capture the end of a service, I'm going to make this class iDisposable. And if we log a message there in the dispose method, we will be able to see the end of the service. We get the start, we get the end. Let's add a method that could be called in the middle. It will output this method is called by this instance. Okay, we have the inspector. Now let's take a look at what will happen if we register it as a singleton service. To use the inspector, I'll inject it into weather forecast controller. As we all know, the injection happens on the constructor. That means when weather forecast is requested for the first time, it will ask the dependency injection container to create an instance of the lifetime inspector, and the constructor of inspector will then output the message that we put there. And that will be the beginning of the service. Here I'm going to call the inspect method when weather forecast is requested. And that will tell us which instance is currently injected. It isn't very clear at this moment when the service will be disposed. Let's run the application and find it out. Let me save some space by close the Explorer. Oops, I was intending to call .NET Watch wrong and typed it the other way around. Let's go along with it. There's no output from the inspector yet. That's because weather forecast controller hadn't been constructed. I'll curl into it, and you'll see the second I do it, if everything goes as we expected, the constructor of the inspector will be called. And then the inspect method. We see the creation, we see the inspect method. We haven't seen the dispose. That is because this inspector is registered as a singleton, which has the same lifecycle as the application. So the dispose will not be called until the application is stopping. Let's try to see if that's the case. Well, as soon as I pressed Ctrl+C to stop the application, we see the message saying lifetime inspector is disposed. And this is a lifetime behavior when the service is registered as a singleton. It starts on the first injection and stops when the application quits. Let's take a look at how the same service will behave if it is registered as a scoped service. Instead of calling add singleton, I'm going to call add scope on the same service. That's the only change that I made. And let's start the app again and observe the behavior. I'm going to do the curl again. As you can see, the start of the service got called, then inspect, then disposed immediately after the request finish. Let's do the request again. There's another cycle of creation, inspect, and dispose. If we pay attention to the ID, we will also see that they are different, meaning they belong to different instances. And this is a scoped service. It starts when a request happens, and it got disposed when the request is gone. Okay, let's take a look at the lifetime for a transient service. The differences in between a transient service and a scoped service is that when it's rejected multiple times in a request, a scoped one will remain the same, while the transient one will be created every time it's injected. To see it by ourselves, let me update the weather forecast service. Here I'm going to inject the inspector again. This code doesn't actually make sense. In real life, this kind of multiple injection could happen when you have multiple services depend on the same service, and that service got injected multiple times. In other words, this could happen. And let me update the get to call the inspect on the second inspector. Let's see. Okay, the lifetime inspector is still registered as a scope. I'll run it as is, and then I'll update it to add transient later and see how the behavior changes. Here I curl it, and we can see there is one creation, two inspect, and one dispose, all share the same ID. Same pattern if I curl again, just different instance ID. Now let me update the registration, changing the lifetime of the service from scoped to transient. And since I have Watcher running, the app got restarted automatically. Let's see what will happen if I run curl to the endpoint this time. Oh, now this time we have two creations, meaning the constructor of the inspector has been called twice. And the inspect method has been called on two instances respectively, and also followed by two disposes. And that's the behavior of a transient service. Every injection leads to a new instance. I hope the concept is clearer now. At this moment, we all know there are three types of lifetime for a service in the dependency injection container. Which one should I use? There are several considerations. One angle is to align the lifecycle of the state of the service to the appropriate lifetime. For example, if we need a cache to live longer than single requests, then we will register the cache service as a singleton service. If the state of the service only need to live as long as a request, then register it as a scoped service. For example, In the common case, the authenticated user info will usually has the same lifespan as the request, and we will register user service as scoped service. For transient lifetime service, those are usually services that doesn't hold any state. For example, a service to sum up two numbers. You don't need to hold the result or any, it's pure computing. There are other considerations as well. For example, if you register a service as a singleton, since it will have the same lifetime as the application, any small leak will add up. On the other hand, if you register a lot of transient services, every time they are requested, there will be an instance of it. That will take up allocation time as well as memories too. There's probably a process of try and learn before we can come up with our ways to determine which lifetime to use. Let's try it on the DogReport service we've been building. Let me bring over the classes from last example. We have been created docs for printing on the ad hoc basis. Let's create a repository for docs this time. I treat a repository as a in-memory copy of the database, and there is a method to return doc instances. There could be other methods like adding or something like that. I'm just going to ignore it for now. For the demo purposes, I'm going to create a mock repository of the docs. And I'm going to put in some dog records by the constructor. There's a Chihuahua Bella and Q, and he's a pit bull. And the constructor name is incorrect. It looks like it's generated from the file name rather than the class. Let's register the dog repository. Repositories, just like caches, will live longer than requests. I'll call add singleton. The type for the service will be iDogRepository, and the implementation class would be mock.dogRepository. Now let's think about the DogReport service. The report by itself won't hold any object that need to live longer than a request. That leaves us to choose from either scoped or transient. I'm going to do the scoped here so that the service won't be created multiple times within a request. It probably would also work if it is registered as a transient service. As we learned before, we will need to register all the dependencies for the DogReport at the same time. So we need a service of iSerializer and iOutputter. Let me register them one by another. Now let's inject both the repository and the report to weather forecast for use. Instead of calling the fake inspector here, I'm going to call DogReport to print each of the dog from the repository. Now let's run the code. Between the lines, we see two dogs being output here. And if we run it again, there are another two lines of dogs. Based on our understanding of the service lifetime, the dog records that has been output here are from the same instance of the dog repository, while the service that prints them are different between the two requests. Thanks for watching. I hope you have more understanding of service lifetimes in dependency injection at this moment. If you like the content, please press the like button to let me know. Subscribe if you want to get notified when the next video is available. I'll see you in the next one. Until then, take care.